Now, the last thing I want to talk to you before we go on to heart failure is talk to you a little bit about the engine, the myocardium, specialized cardiac muscle cells. Well, I mean, this is skeletal muscle cells in the bicep. Then how come this engine, this muscle, cannot work more than an hour before it fatigues, before it's overcome and it's drowned herself in lactic acid? How come this engine, which is no bigger than your fist, can pump 5 liters of blood every minute, 300 liters an hour, 7,000 liters a day, 250,000 liters a month? How does it do that without fatigue? But the answer lies not so much in its chemistry, because the cardiac engine is striated. That means it has the same proportion of actin and myosin in its chemistry. And yes, it is infiltrated with billions more of mitochondria, hence ATP and energy. But that doesn't make the cardiac engine efficient and special and specialized. The answer is the size of the cardiac engine and the way they're connected together. The skeletal muscle cells in the bicep are centimetres in length, 100 microns in width, multi-nucleated and featureless compared to the cardiac engine. The cardiac cells are individual cells, single nucleated, 20 microns by 100, 20 microns by 100. And these individual cells are connected to the neighbour by a special gap junction, an intercalated disc. And that means now there is a rapid transfer of ions possible between cells. Cells can communicate together. So potassium and sodium and chloride ion can go from one cell to the next unimpeded, without there being a gate. But more important than that, these intercalated discs connect the cardiac cells, not as if they were building a wall with it, but as if they were building a pyramid with it. The cardiac cells do not just connect together in any random way, they individuate with one another in a step formation to give the heart the rigidity, the strength, the colossal power that it requires. Because that is, after all, what we want, isn't it? We want a strong heart, don't we? We want a heart that is going to generate enough pressure during systole to pump that blood from the left ventricle into the aorta. And these intercalated discs allow for that. But more important than that, they allow electricity through, action potential. So if you were to get a pacemaker and place that pacemaker on the right auricle, on the right collecting chamber, and if that pacemaker were to fire an electrical impulse like it does every second or so, that electrical impulse will sweep through the entire myocardium. And you hear the lub, and before you've heard the dub, the heart is contracted as if it were just one cell, one unit, a functional syncytium. And that's precisely what it is, isn't it? A functional syncytium.